Yeah. So, let us start the class. Do you have any question? Do you have any question? So let us go continue with that what we were teaching in last class. So before that, let me share my screen. Can you hear me?
Yes, sir.
Okay. Okay, so we are discussing the symmetries and conservation laws, and third symmetry that we were discussing was rotational symmetry. And this rotational symmetry, this is a special case. We are considering the rotation about z axis. So we are considering the rotation about z axis. And then suppose this is my position vector at any time. This is r, and this is some later time, so r plus delta r. And this angle I am considering that angle with z axis, and the r is phi. This is the center. This circle is perpendicular to z axis. This is like this is z axis, and it's perpendicular to that. So this angle will be 90 degree. This angle will be 90 degree. Okay. And then we often in last class that delta r was given by delta r. This quantity was this. Let me write. This is some OP. So OP OP and d theta. Okay. This arc will be the radius. Suppose this is the radius, and then this angle. So arc will be d theta, and OP we calculate. OP we calculate from this triangle. This is OP, say this point is Q. So OP is calculated, it is right angle triangle. So OP was R sine phi. Right? This angle is phi, so this will be OP, and this angle is 90 degrees. So R is PQ, so R sine phi. And then this we substitute, then we got delta r was r sine phi d theta, or the small angle, which I wrote it z cross r, unit vector z cross
Sir,
r d theta.
sir, angle QOP is 90 degree.
Angle QOP is 90 degree, yeah, because this whole circle is perpendicular to z axis. That I explained. This is a two-dimensional figure, but this circle is perpendicular. The whole circle is perpendicular to that. Okay. So this z cross r. So now if I go back to my Lagrangian, I consider r function of r dot. Okay. So if you have this Lagrangian, then calculate the delta L, the change variation of Lagrangian will be del L del r. If it is a, let me write in terms of vector. So r and r dot are vector. So differentiate with delta r plus del L del r dot vector dotted with delta r dot. Okay, delta r already has I have calculated, and delta r dot, if you calculate delta r dot will be This is only this will be the z cross z no unit vector z cross r vector. Okay, so this if we now substitute, so what, and if you have many I, suppose you have more than r, so it will have r summation over I, this is r, this is okay. If you have this summation is for both the terms. Okay, so let me write this sum over I del L del r is ddt ddt of del L del r I vector dot. Okay, because Euler Lagrangian equation is ddt of del L del r dot equal to del L del r. So del L del r we are substitute through this. Okay, then dotted with this, so this, so z cross r d theta. Okay, and then this will be p theta, right? This is pi, so pi vector dot, this will be pi vector dot product z cross r dot vector d theta. Summation is for both the terms. So let us do everything in this page. So let me erase this initial portions, and then we'll finish the proof here. And so this is my delta L. So delta L. Now this is again p dot I, and d theta is does not has anything to do with this time derivative or summation, so I take d theta outside, no problem with that. And pi dot, this is your pi, del L del r dot is pi, pi is del L del r dot. So if you have vector, you will
Sir,
have vector. Yeah,
sir, how did you took d theta out of the bracket summation?
because theta has no I. Summation is only over I.
Okay, sir. Okay, sir.
Pi dot z, this is a vector, this z cross r, and this will be pi dot z cross r I dot vector. Okay. Now I'll be using some vector identity. Let me tell you that what vector identity I'll be use. So if you have a dot b cross c, then this vector identity verify yourself, b dot c cross a, same as c dot a cross b. Okay, so this vector identity you verify yourself.
Sir, yes, sir.
That vector, yeah, this vector identity will be used for these two terms. Okay, so this term, let us, this is my a, this is my b, this is my c. So this term, so let me write delta L can be written as d theta and then sum over I. So z will come first, so z dot, then r cross p dot, r cross ri, actually I am using I now because ri pi, ri vector cross pi dot vector. Okay, this way. So I am using just this equal to this. So b dotted, so b is now my z unit vector z. So and then r dot r cross, this is dot and they are cross. Similarly, if I applied the second term, again z cross as b, then dot, then r dot cross ri dot cross pi. It's not visible. Let me plus z unit vector dot z unit vector r I dot cross pi. This everything inside the sum of I. Okay. So now
Okay,
this
sir.
will be z also you can take outside sum because z has nothing, no I. So d theta we have, d theta is the it is almost irrelevant now. Z z unit vector dot sum over I. In both places z unit vector. So one term is r cross pi dot and other term is ri dot with pi cross pi. So this will be equal to now d theta z dot. Now look at this, is pi dot ri is no dot, ri dot no pi dot. So this I can write sum over I ddt of ri cross pi, right? So if you have a product rule of differentiation, when this will be differentiated, this will be unchanged, this will be differentiated, this will be unchanged. So this is, and this quantity d theta now dot, then sum over, this is li, sorry, let me write mi, angular momentum, angular momentum for the ith particle, where mi is my angular. L I am not writing to, because then you will be confused with the Lagrangian. So that is why I am not writing the. So where m is my angular momentum, m is angular momentum r
Sir,
cross t. Yes.
sir, sir, can you
Ah,
please repeat that statement?
which statement?
D theta. Sir, which you just gave for d theta z cap dot sigma mi. You
Do
told that
you know
we
what
will
is?
get confused if you.
No, we just ddx of fx gx. Can you tell me the formula? What is this?
Yes, sir.
Tell
Yes,
me.
sir. Gh into f dash h minus fh into g dash h upon gs का square.
This
हाँ.
you don't know differentiation then.
Sir, I told
No,
fh,
no.
no sorry, gh
You
into f dash h minus
minus.
fh into g dash h
Hmm.
upon gh का
No,
square.
sir.
Mixture Dixit. You don't know differentiation. Why don't you study first differentiation? 11th class, get a book from 11th class and then study differentiation.
Sir,
Then
I
you
am
come to
studying
this
way
order.
too many chapters, sir. Sir, I am
I'll throw you
studying
out
way
of
too
the.
many things at
So
the same time.
if you write that differentiation of two product function like this, then I'll throw you out of my class. You are not eligible for my class. First, you learn the what is
So
the
g dash h
differentiation.
square then.
I'm not going to listen anything from this answer. You ask your friend what is the mistake you have done doing. If you don't know differentiation, then you are disturbing my class, right? So first you learn differentiation. Every day I'll ask differentiation in my class. And if you cannot, then that point I'll throw you out. So today I'm giving you warning that you come learning
Sir,
to the
what if
class.
I have a doubt and sir, what
No,
if I
you
have a
don't.
doubt and
See,
you can't answer it properly?
so can you leave the class, Utkal? Just you leave
Sir,
the class.
rules
Don't
are
enter in
for
the class.
everyone, right? Equal and sir, rules
You
are
don't
for
know.
everyone. Same.
Mr. So listen to me. It is my class. Whatever I'll
Okay,
decide,
sir.
it will be, that is the final. You don't know differentiation.
But sir, I have my
Or
rights
at
as
least,
well, sir.
no, you cannot ask differentiation in my class. You cannot ask, sir, 1 plus 2 equal to 3 or 4. You cannot ask in my class. Whether 2
Sir,
plus 2
I
is
didn't
5.
ask you about differentiation. You asked me to tell the differentiation of fh
No,
into gh, considering
you
that
say,
it will be important for you to let me understand this concept clearly. But sir, I made a mistake. Sorry. Everyone makes a mistake, but that doesn't mean you are able to kick him out of the class.
can you, yeah, I'm leaving.
Sir,
Can you
there
leave
is
the
no
class?
place in ego between a teacher and student. So don't put
Leave
your
the
ego
class.
between us.
You leave
Sir,
the
you
class.
Sir, I
please
will leave
remove.
the class, but I will take action
I,
against you as well.
yeah, you
I
just
will talk to
take
the
action.
HOD and the dean.
Yeah,
So you have too much of an ego.
This class
I
is
saw it
recorded.
in the practical lab as well. Uh, that's way
This
too
is,
much fine, sir. I couldn't have asked anything more. That's way too good for
go,
me.
leave the class. Leave the class. Go to head,
Okay,
dean,
sir.
vice
Okay,
chancellor.
sir. Okay. Thank you, sir.
Okay,
Thank you, sir.
okay. Leave the class. Okay, so let me continue with that. So mi I am defining as the angular momentum of this, right? I am not using, generally people use L equal to R cross P. So so to avoid a confusion with Lagrangian, so I'm just writing. So mi, ith particle angular momentum, will be Ri cross Pi. So this is the sum over all the angular momentum, but there is a dot product outside with z component. So d theta is this time total angular momentum. That means no ddt, sorry, this is angular momentum. So there is a little mistake. Let me clear and write this step. Let me write d theta z dot ddt of m, where m is sum over mi, all angular. Okay, so this means, so now we have started with, let me finalize this. Let me tell you that we started with the rotational symmetry about a z axis, and we find that if the Lagrangian remains invariant, if the Lagrangian remain invariant, then delta L should be equal to 0. So that means d theta ddt of mz, now this is z dot product with m total m, so this will be 0. That means d mz dt will be 0. Okay. So that means if I have a rotation about z axis, then angular momentum of z component is conserved. So this is, I'm not considering any full rotation, but I'm considering a special case of rotation, and we found that angular momentum corresponding to, so if I have a rotation about z axis and the system is dynamics is invariant, then we find the z component of angular momentum is conserved. Okay, so this concludes that our discussion on the symmetries and conservation laws. Do you have any question? Anybody has any question? Okay, so now, let me summarize this topic, the symmetries and conservation law. So symmetries and conservation laws. So this we consider three symmetries. One is the translational in coordinate, translational symmetry, which is also called the homogeneity of space. Second thing we call translation in, so translational symmetry, translation in space, translation in time. So this is homogeneity in time. Third is isotropy. Isotropy of space. This means rotational invariant. We found in this case total linear momentum is conserved. So total, let me write with red. So this is linear momentum. This we find the total energy, and this is we find the angular momentum. Okay. Also, we can think that R is cyclic here. R is cyclic. T equal T is cyclic. Here, the angle angular variable, in this case, in the example, it was phi. So angle variable is cyclic. Angle variable is cyclic. Okay, now these three examples we consider. Now we want to say that if there is a partial symmetry, suppose if I write a Lagrangian partial symmetries. So let me write partial symmetries. Okay, so partial symmetries means that, okay, I have, suppose Lagrangian is x, y, z, and then x dot, y dot, z dot. Suppose there are three variables. X going to x plus a, it is symmetric, but so if this is a symmetry, but y going to y plus b or z going to z plus c are not symmetric. This is called partial symmetry. So I'm not taking the full r going to r plus a. I'm just only considering that x going to x plus a, the Lagrangian is invariant, but y going to y plus b or z going to z plus c, it is not. Okay, so this is not invariant. So what will happen in that case? Total momentum will not be conserved, but px will be conserved, because it is the symmetry with respect to x variable. So px, momentum conjugate to x variable, will be conserved. Py and pz will not be conserved. Okay, I may consider a Lagrangian to tell you that Okay, so this suppose a Lagrangian x and y, suppose an x dot y dot, just for simplicity too. So a half m, say x dot square plus y dot square minus a half k y square. Now you can see this Lagrangian is invariant x going to x plus a, because there is no x term. So x going to x plus a, it will be invariant, and x dot, it will be x dot, right? X dot, suppose prime, x prime going to x, so x prime dot is x dot, because a is constant. So this term will be remain invariant, but there is no x in this side. So this term for this Lagrangian, px will be conserved. But not py, because y is there. So if I change y prime equal to y plus a or b, then it will change, and it is not invariant under this translation of y coordinate. So it will be py will not be conserved, because there is a force in the y direction. You can understand this is the harmonic oscillator force, right? So force corresponding potential energy. So this, but there is no x dependent terms. So there is no x component of force. So that is why momentum is conserved. Right? All these are familiar knowledge. Similarly, in the case of angular momentum, let me give you an example. Time, there is only one component, so there is no question of partial symmetry for the time. Homogeneity of time, there is no possibility that it will be partial symmetry. Okay. Now, if I consider, for example, in angular momentum, partial symmetry in angular momentum, let me see. This just I'll tell you with an example. Suppose I consider a Lagrangian x, y, z, x dot, y dot, z dot equal to say half m x dot square y dot square plus z dot square minus say half k x square plus y square plus half or minus half k1 z square. Suppose I write a simple harmonic oscillator. Now if you consider two rotation, I'll consider. So first rotation is about z axis. Okay. So about z axis. So z axis rotation. So it will be x and y. So x prime, y prime will be cos theta, sin theta, minus sin theta, cos theta, x, y, right? But now if you can verify yourself that x square plus y square, this is will be x prime square plus y square, and also the derivatives. Z is remain, when you have a rotation about z axis, z will be remain as it is, right? No changes, only xy. If you have a rotation about z axis, rotation xy coordinate will change, and this they change, and you can have. So this term is invariant. This doesn't change. This term is also invariant. This doesn't change. So this Lagrangian is invariant under rotation about z axis. Okay. This about z axis. So I can immediately say that mz will be conserved for this. But now if you consider a rotation about say x axis, Okay. So rotation R2, let me write R2, rotation about x-axis. So what will have? I will have prime and z prime, and similarly y and z, right? But now y square term has a coefficient half k, z square term has a coefficient half k1. So this half k1 y square plus half ky square plus half k1 z square, this is not invariant under R2, this rotation about x-axis. Of course, x is invariant, so this term will be invariant, this term will be invariant, x is not changing. But y square plus z square, this term also will be invariant because it is common coefficient m square, m. But here is a different coefficient. Okay. So you know that if I have a rotation, the length of a vector remains invariant. So length of a vector means x square plus y square or y square plus z square, depending on which plane you have. So in this case, you will have, it is not invariant. So I can immediately say that mx is not conserved. Okay, so this concludes your symmetries and conservation laws. If you have any question, anybody has any question, I'll answer. Otherwise, I'll move to a new topic. Okay, so nobody has no question. So let us. So two input. So by the way, I'll not take class on Saturday. Saturday I'll be out of campus, so I'll not take class. But I'll try to see. And next week also, both of your class, Thursday and Saturday, are holidays, puja days. So next week also probably I'll not take class. But if there is a possibility and you people are free, then I can take class on. I'll decide because I'll be out of campus. So depending on my network and availability, I'll if I get a strong network, then I'll take class. Otherwise, next week also I'll not take class. Most likely I'll not able to take class, but anyhow. So this so keep in mind that Saturday I'll not take class, and next week also I'll not take class. So then after 17 week, 18 week, starting with 18 October week, we'll take class. But in between, I'll be in contact with the mid-sem exam. I asked in the department, and department head says that they will decide it, and there will be teachers meeting or something. So there is no clear instruction from the head that it has to be taken on the before Dashera. But I'll take mid-sem exam probably before your Deepavali. So in the end of October, there will be mid-sem from my part. Okay. So whether I'll take a offline, I may take a offline exam also. Those who are present, I can take a offline exam, and I can also take those who are not present. For them, I can take a offline. But those who are present and occupying hostel, then they have to give the offline exam. I'll arrange the classroom, etc. So I'll get the hostel list. Those who are in hostel, they have to give the offline exam. But I'll take online exam, and there will not be like that offline exam will be difficult and online exam will be easy, not like that. So don't worry about that. Okay. So two important topic I want to cover today I thought, but at least one of the topic I'll able to cover. So that is called one is the let us call the mechanical similarity. Mechanical similarity, and another topic, virial theorem. Virial theorem, but this will not consider today, we will have time. So mechanical similarity. Mechanical similarity is based on the properties that Lagrangian, if is multiplied by a constant term, then the dynamics of the system does not change. These properties. So let me consider a Lagrangian, which is Ri, Ri dot or Vi. You can write Vi and T. Suppose this is a Lagrangian, and which is also we consider as the kinetic energy minus potential energy. We assume that two things, that T is a homogeneous function of generalized velocity of Vi. So this is Vi, so no dot here, no? Vi. So homogeneous function of Vi of degree 2, quadratic. So kinetic energy is quadratic. That means velocity power 2 always, and we are assuming the homogeneous function. Okay. Second thing, we will be assuming that this potential energy is only function of Ri, and also it is a homogeneous, again homogeneous function of degree, say k. This is it is always so only function of Ri and homogeneous function of degree k. K can be 1, can be -1, k can be 4, k can be etc. etc. So for example, harmonic oscillator, k is 2. For Coulomb's Kepler's problem, it is k equal to -1, so on. So two things I am assuming, and both are very reasonable assumption. First one is that it is kinetic energy is homogeneous function of degree velocity of degree 2, only velocity on degree 2, and potential energy is homogeneous function of coordinate of degree k. Potential energy does not depend on the velocity. Okay. Now I change my coordinate by multiplying. Suppose I write Ri prime is alpha times Ri, and T prime is beta times T. Alpha, beta are constants. That means I scale, it means I scale the coordinate and time. Scale means, okay, meter scale, right? You have some centimeter, meter, so centimeter to meter 100 times multiplication. If you multiply meter by 100, then it will go to the centimeter. Or if you divide, if you multiply centimeter by 1 by 100, if you multiply by 1 by 100, that is divide by 100, then you will go to meter. So it's just a constant multiplication. And we want to see that how this affects on this Lagrangian, with this Lagrangian, and assuming these two things. Is that clear? Okay. So let me tell you here how. So V will be scale. So V prime will be, V is dr dt. So V will be alpha times beta by Vi, right? Because V equal to dr dt. So r scale by alpha, t scale by beta. So V will scale by alpha by beta. Okay. So kinetic energy will be scaled by, tell me. Shraddhanjali, can you tell that how this T prime will be related to T?
Sir, it will be alpha square v square time. Sorry, alpha square by beta square times.
Yeah, so alpha by beta whole square times T. Why? Because T, I am assumed that it is function of V square. All the term is function of V square. So it will be alpha by beta whole square. So T will be changing like this. Shayan, can you tell me how U prime will be related to U? U is a only function of Ri and it is a homogeneous function of degree k. From this information, can you tell that how U prime will be that?
Sir, alpha to the power k.
Very good. So it will be alpha to the power k because every coordinate is scaled by alpha. There are, every term has k r, k times r or r to the power k. So it will be alpha to the power k. Everybody agrees with that? Okay. So now what will happen? Let me, then my Lagrangian, what will happen? So let me go to my Lagrangian. Okay. So my Lagrangian L prime is T prime minus U prime. So T prime U prime, now T is alpha by beta square times T, and this will be alpha to the power k times U. Okay. So this is straightforward. Okay. Now I want to use this formula. So if I want to use this formula, then it is not possible because this term and this term is different. So I cannot make a overall constant. But suppose I demand now, suppose alpha beta two unknown parameters, but let me choose my beta in such a way that alpha by beta to the power 2 square equal to alpha to the power k. That means my beta, I'm choosing my beta square equal to alpha minus 2 minus k, right? This implies beta square, I'll go right side, so it will be beta square, alpha k will come in the denominator, so alpha to the power 2 minus k. So if I choose my beta equal to alpha to the power 2 minus k by 2, now initially I had two unknown constants. I have only one, only alpha. Beta I choose in terms of alpha. Then it is possible that I can take common that overall command, whatever it is, alpha by beta whole square, or you can take okay, alpha by beta whole square times your L. This is also alpha by beta, so this alpha by beta whole square times, if we choose this beta. Or you can write also this is alpha to the power k times alpha. Both are same, right? That means again in this form now. So I can say that if I scale that r prime going to alpha by ri and t prime is alpha to the power 2 minus k by 2 times t, then the Lagrangian is just overall multiplication, does not change. So under this scaling, let me write, under this scaling, dynamics of the system will not change. Okay. Dynamics of the system will not change. Two minus k. Okay. So everybody agrees to that. So we get a good result that I can change my coordinate at time by a scaling. Scaling means multiplying. Then my Lagrangian, the dynamics of the system. So what does it mean? Meaning is that in the configuration space, I have a path. Now I multiply the every point and time, so I can get a extended path. So if I go this and or in the L prime is like this, then dynamics does not change. So it has a important consequence that I'm going to tell you in next 10 minutes. What will be the consequence that I'll tell you. Just let me see one important. Okay. Okay. So okay, very good. So this is important for us. Let me erase this part, which is not important now. So if I choose my alpha as that this is my initial path, this is my old path. So this point to this point. So this length scale in this path is L, length scale in this path is L prime. Let me choose my alpha equal to L prime by L. That means it will be the same path, same size, same shape, but different size path. Right? So replacing the old path by a new path, let me say that length scale in this is L, length scale in this is L prime, and I'm choosing my alpha equal to this. So immediately then I can write my this transformation in terms of L. You may have little bit doubt about this L and L prime, but this will be clear when we consider the examples. So your R prime will be L prime by L times Ri, and T prime will be your L prime by L to the power 2 minus k by 2 times T. So under this scale, it will not change anything. Okay. Now I consider few examples, then situation how this is important, that under this scaling or this scaling, your dynamics will not change. So this problem is called mechanical similarity between those two systems. So this let me consider few example and how this gives you the information about a system without solving anything. For example, let us call a simple harmonic oscillator. Simple harmonic oscillator, potential energy is half k x square, half say potential energy, let me write half m omega square, half m omega square x square, right? So in this case, k equal to potential energy is k is the order of homogeneity of the potential energy. In this case, k equal to
2.
k equal to 2. Good. So k equal to 2. So what will happen? Let me see. If k equal to 2, then let us consider to that k equal to 2, then this power will be 0. So t prime will be t. So that means time period t is some time. So time period is also some time. So time period is independent of the amplitude of the length scale. Length scale is amplitude is the length scale. Amplitude. And that is the simple harmonic oscillator. When you have a simple harmonic oscillator, whether it is oscillating with the length L or L prime, this total distance, it does not matter. Time period is both cases same. That information we are getting from just from the simple logic, which is this mechanical similarity. So that means, so simple harmonic oscillator we know, but there are many systems whose information we don't know, but we can guess or we can find some information about the actual system by these scaling properties, mechanical similarity. Okay, so in simple harmonic oscillator, the time period is independent of the amplitude that you are familiar. That result I derived from this, I obtained from the mechanical similarity. Okay, another example. Let us consider another example. So example 2, a free fall. Free fall. So potential energy, you will be, free fall will be mgz, right? You just release a body from a height h, and then it allowed to fall freely. So anytime its potential is mgz, that is the gravitational potential energy. So k equal to 1. K equal to 1. So t, what will happen? T prime, if I put k equal to 1, so it is L prime by L to the power half. 2 minus 1 by 2 half t. That means t is proportional to root over L. And that is the situation for a free fall. You all know the dynamics of a free fall, that time period of fall proportional to square root of the length it has fallen. Okay, but nice example is the third example. Third example, let us call Kepler problem. Okay. So in the Kepler problem, your potential energy is some say constant times minus constant times r. Kepler 1 over r potential. That means k equal to minus 1, right? K equal to minus 1. It is 1 over r. So now what will happen? K equal to minus 1. So it will be, t will be minus minus plus. So t prime will be L prime by L to the power 3 by 2 times t. That means t square is proportional to a q. Kepler's third law. Time period is proportional to the, time period square is proportional to the cube of the semi-major axis. This is, so I'm not saying that you will get exact formula, but you will get a actual information of the system by using this mechanical similarity or the scaling property. Okay, any question on this? Virial theorem we wanted to cover today, 15 minutes, but because of the disturbance and this, I could not cover. But I'll teach virial theorem in next class, next possible class. Any question? Otherwise, we'll stop this class. Okay, but you study and most likely I'll take the offline exam in before Deepavali, but department will decide. Department may announce the date, but if they announce date, then we have to stick to that date. Otherwise, at end of the October, I'll be away from 19 to 17. I'll come back on 17. Then 18 onwards, I'll be in campus, so no problem. And in between, if you have any doubts, whatever I taught in the class, this is my 10th lecture. So go through all these lectures, solve problems. I'll try to share a problem sheet with you in this group and solve those problems. And if you have doubt, you can write me in WhatsApp or in group. No problem with that. Okay, so let me stop the class.